Last lesson we talked about trapezoids, parallelograms, and kites. And we're going to get more in detail about parallelograms today. So just a reminder, parallelogram is a quadrilateral, a four-sided figure, with both pairs of opposite sides being parallel. And we used the slope when we were working with things on our last set of notes. And now we're going to look at some more features of a parallelogram. First one, not only are opposite sides parallel, but they're also congruent. So the way that we find the length is we use our Pythagorean theorem. Opposite angles are congruent, and we'll look at that pretty quickly here in a minute. And then the one that I want to highlight is that the diagonals bisect each other. They have the same midpoint, and it's the diagonals that sometimes cause trouble, because if you think back to it, kites had diagonals that were perpendicular, and now we have parallelograms have diagonals that bisect each other, and that's the one that we really need to continue to practice so that we can remember it when we're taking the OST in April. But let's look at a few examples here. Example 1. Quadrilateral RSTU is graphed below. Determine if the quadrilateral is a parallelogram by showing the opposite sides are congruent. Again, you might want to use colored pencils just to keep track of things. For me, it's nice because I can start and have another page here with the same picture to get us going, so it won't get quite so jumbled up. But when we take a look at this, what we want to do is we want to find the distance between RU and ST, and we can start by drawing our triangle here. And when we count, we've got 1, 2, 3, 4, 5, and 1, 2, 3. Again, when we're proving that these are congruent, we're using the Pythagorean theorem. Start far left on your paper so you have enough room. It's going to be 5 squared plus 3 squared equals c squared. Side squared plus side squared equals hypotenuse squared. So we get 25 plus 9 equals c squared. 25 plus 9 is 34. And when we want to figure out what c squared is, or we don't mind what c squared is, but we want to know what c is, I'll take the square root of both sides. Once again, c is the square root of 34. And you can type that in a calculator if you want an actual value. But what we're looking for is we want to show that RS is congruent to ST. So we'll do the same thing over here with ST. We'll draw a triangle. And what we're going to find is we've got 1, 2, 3, 4, 5. And we have 1, 2, 3. And the same thing's going to happen. We've got 5 squared plus 3 squared equals c squared. We've got all that work right beside it. So we end up with c equals the square root of 34. And so far, so good. Because once again, what we're doing is we're looking at opposite sides are congruent. So we've said R, let's write it down, RU is congruent to ST, or TS. But now we've done those, we need to look at the other pair of parallel sides, which is going to be the RS and the UT. And again, you might want colored pencils just to keep track of it here, but if we draw our triangle and use the Pythagorean theorem, we've got 1, 2, 3. Nice that my blue 3 works out there. And 1, 2, 3, 4, 5, 6, 7, 8, 9. So in this particular part, 3 squared plus 9 squared equals c squared. Feel free to use Desmos. Feel free to use your calculator, whatever works for you. Well, we get 9 plus 81 equals c squared. 9 plus 81 is 90 equals c squared. And then we're going to take the square root of both sides. And we get c equals the square root of 90. Again, if you want the exact value, you can type the square root of 90 into the computer, into your calculator. But we've got a length now. That's the length of RS. Let's figure out what the length of UT is by drawing our triangle here. And what we have is we have 1, 2, 3. Then we have 1, 2, 3, 4, 5, 6, 7, 8, 9. So once again, we've got 9 squared plus 3 squared equals c squared. Same values that we had in the previous, which ultimately is going to mean that c equals the square root of 90. And what we were trying to say is, do we have, when we go back now, determine if the quadrilateral is a parallelogram by showing that opposite sides are congruent. So RU is congruent to TS, but we also have RS is congruent to UT. Same picture. Now we want to show that the diagonals bisect each other. And again, if we look back up at our chart, when we're showing the diagonals bisect each other, we're finding the midpoint. And when we talked about the midpoint, we did these problems with a formula, but then we came up with an alternate way, because how many formulas are you really going to remember in April? Not as many, probably, as we would like. So what we're going to do, again, we want to find the midpoint of US here, for starters. And I don't want to graffiti up the picture too much, but what we did is we counted, and we counted from low to high. So it's still kind of a triangle idea here. What we did is we went from here to here. So we went up 1, 2, 3, 4, 5, 6, 7, 8. We went up 8, and we went 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. We went right 12. But what we're trying to do is we're trying to find the midpoint. So the midpoint is halfway through. So instead of up 8, let's go up 4. Instead of right 12, let's go right 6. 4 is half of 8. 6 is half of 12. Remember, we started at the bottom here, so we're going to go up. 1, 2, 3, 4. So we went up 4, and then 1, 2, 3, 4, 5, 6. There's our midpoint. And that ordered pair, let's just write it. Our midpoint has an ordered pair of 1, 2, 3, 2. But that's only one diagonal. Again, what we're trying to show is we're trying to show that the diagonals have the same midpoint. So if we go here for our other diagonal, looking at the midpoint of our T, we're going to count from the bottom up, kind of making a triangle here, and that's where it's helpful to have a different color. But if we draw here and here, so what we did is we went up 2, and we went up 2, and then we went 1, 2, 3, 4, 5, 6 left. That's 6. Again, midpoint, halfway in between. instead of going up 2, we're going to go up 1. Instead of going left 6, we're going to go left 3. So up 1, and then 1, 2, 3. Sure enough, the midpoint of that diagonal, I'm going to put midpoint of RT, I'm going to label a little bit better, also equals 3, 2. Then add in here midpoint of our original diagonal, which was the US. And now we've shown that the diagonals have the same midpoint. Number 2, parallelogram ABCD has coordinates 7, 1, -2, -2, and 0, 3. And we need to find the coordinates of the fourth point. So we've got a couple choices. But let's start by graphing here, and we've got 7, 1. So what might be helpful, and maybe only to me, but just to get the axes in here a little bit better. So I'm just going to highlight the axes here. And now that we've got that, we can graph. So 7, 1. 1, 2, 3, 4, 5, 6, 7, 1. Here's A. -2, 2. -2, -2. Here's B. 0, 3 is C. And we want to find D. So what we've got so far, we've got that, oh dear, and that little bit of disorientation is what we have. So now what we want to figure out is, well, what is point D? And when we do this, I wish that my picture was a slight bit better. I'm going to color code it a little bit here, and this one is 0, 3. But what we could do, remember, because the definition of parallelogram is that we've got 2 pairs of parallel sides. So we need to have the same slope. So we could do that. We also could do distance. I think that slope will be slightly easier. Remember that slope is rise over run. So if we draw in our triangle here again, and super disoriented all of a sudden, but when we count 1, 2, 3, 4, 5, and I can hardly count here, 1, 2, 3, 4, 5, 6. And then we went 1, 2. So we rose 6, we went 2 to the right. So our slope here, and I'm going to have to redraw this picture. Try the slope one more time now that the board's not so disoriented. Rise over run. 1, 2, 3, 4, 5. And then we went 1, 2, right. Rise over run is our slope. So what we need to do is we need to have another segment that has a slope of 5 over 2. If we start over here at point A, we can go down 1, 2, 3, 4, 5, and over 2. So I think that the point is here, but let's check it. If we fill that in, and we can actually check it twice. But again, switch colors. 1, 2, 3, 4, 5. We went down 5. And to the left 2. -5 over -2. That works. If we look at the other segments just to check it, depending on the orientation of the board here, but it looks like rise 2 and run 1, 2, 3, 4, 5, 6, 7. 7 to the left, so that would be, let's write it down, up 2, 7 to the left. And if we look at our bottom length now that we've filled it in, again, rise, well, we went down 2, and we went to the right 1, 2, 3, 4, 5, 6, 7. So it's going to be -2 over 7 one negative on both of those fractions. So the point that we need is indeed that point right there, which is going to be 5, 1, 2, 3, negative 4. Flipping our paper over, getting a little bit more into the algebra now. It says in parallelogram ABCD, diagonals AC and BD intersect at point L. If AL is x minus 2 and CL is 3x minus 16, then what is the length of diagonal AC? Well, one thing that I have up here on the board that you don't have in your paper is I have a parallelogram drawn. And I just find it helpful to be able to label it a little bit better if I possibly could. But if we label it here, we've got A, B, C, D, and it says AC is diagonal. So let's put in a diagonal here. And then it says, with our other diagonal, this point right here is L. It says if AL is x minus 2, so here's that length of x minus 2, and CL is 3x minus 16, then what is the length of diagonal AC? Well, what we know is that L is the midpoint of this. So when we set this up, we can start by saying x minus 2 equals 3x minus 16. If it's the midpoint, AL is equal to CL. So we're going to solve it. Solve it the way your Algebra 1 teacher taught you. I'm going to move my letter to the left. I'm going to subtract 3x from both sides. We get negative 2x minus 2 equals negative 16. Add 2 to both sides. You get negative 2x equals negative 14. And then it's negative 2 times x. We need to undo the multiplication, so we'll divide by negative 2 and get x equals 7. The thing is, we're not looking for x. Look back at what the problem says. It says we want to know what the length of AC is. Well, what we just found is that 7 minus 2, that length is 5. I put the 7 back in here for the x. 7 minus 2 equals 5. And again, if L is the midpoint, then 3 times 7 minus 16 better also equal 5. 3 times 7, by the way, is 21 minus 16, and that also equals 5. And once we know those two values, again, what we want to know, one last time, what is the length of diagonal AC? Well, it's 5 plus 5, which is 10. Number 4. Each quadrilateral below is a parallelogram. Find the value of the missing variables. Well, here's the one that we haven't talked about much, which was the property of parallelogram number 2. And that one says opposite angles are congruent. Well, in this particular case here, 53 is opposite to angle y. So right away, we can figure out what y is, because opposite angles in a parallelogram are congruent. So y equals 53 degrees. Then the other piece that we want to figure out is we want to figure out, well, how big is x? This one is asking, find the value of the missing variables. This one is simply asking for x. But a reminder again, back to the qualities of a parallelogram, is that opposite sides not only are parallel, but they are also congruent. So what we can say is 15 equals 4x minus 1. By the way, if you wrote 4x minus 1 equals 15, that is fine. And then we're going to solve. 16 equals 4x, and 4 times x. We're going to divide, so we end up with x equals 4. Again, remember this quadrilateral is a parallelogram, and the thing that we may or not have been told so far is that this angle here and this angle there are supplementary. And once we know that fact, then we can figure out the value of x in this problem as well. Remember, supplementary means adds to be 180. So this is x plus 10 plus 2x plus 20 equals 180. And we'll combine like terms. So we get 3x, x plus 2x. 10 plus 20 is 30 equals 180. And now we have it pretty well in a solvable form. We'll subtract 30 from both sides. We get 3x equals 150. Divide both sides by 3. So we end up with x equals 50. And to finish. Find the value of the missing angle, VXW, if quadrilateral VWXY is a parallelogram. Well, remember, if it's a parallelogram, what we've got is that YV is parallel to XW. Two parallel lines cut by a transversal, alternate interior angles are equal. And we also know that opposite angles in a parallelogram are equal. So if we know 60 here, then this angle over here is also 60. And that's going to allow us to find our third angle. But we can take 60 plus 52 and get 112. And then we can take 180 minus 112. The reason that we picked 180 is because there's 180 degrees in a triangle. And 180 minus 112 is 68. And again, what we just found is we found this angle is 68. But the good news is once we find that angle, again, two parallel lines cut by a transversal. If 68 is up there at YVX, then 68 is also here at VXW, which is what we were looking for.